In this video series, I work through a math problem or problems each video. Rational expressions are fractions where the numerators and denominators are polynomials. Note that since 1 is considered a polynomial, polynomials are considered rational expressions, since we can let the denominator of a rational expression be equal to 1. To simplify rational expressions, we factor both polynomials in the numerator and the denominator, then cancel out common factors. We do have to pay attention to the x values, which make the linear factors we cancel out equal to 0. To let us know not to worry about these exceptions, the directions may include the statement, no denominator is equal to 0. Let's take a look at the example. We need to simplify the following expression. Assume that the denominator is not equal to 0. If we look at this expression, we see that we have a fraction, and in the numerator we have 2x squared plus 2x minus 4, and in the denominator we have 6x squared plus 30x plus 36. Both of these are polynomials, so this is a rational expression, and we can go ahead and follow the directions that we just discussed. So let's go ahead and first factor both polynomials. The polynomial in the numerator, if we look at all the terms here, they have 2 in common, so we can factor 2 out from the polynomial. We get two multiplied by x squared plus x minus 2. If we look at the polynomial in the denominator, we see that 6x squared, 30x, and 36 all have 6 in common. So we can factor 6 out from the polynomial in the denominator, and that leaves us with x squared plus 5x plus 6. If we look at the numbers in front of the two polynomials, we have 2 and 6. They are both multiples of 2, so we can divide both of these numbers by 2, which leaves us with just 3 in the denominator. Next, we'll go ahead and factor the two polynomials. The polynomial in the numerator, x squared plus x minus 2, since the leading coefficient is 1, we know that when we factor this polynomial, we get x and x in each of the parentheses, and 2 is equal to 2 times 1. Since the sign in front of 2 is a minus sign, one of the numbers here should be positive and the other should be negative. Since the linear term has a coefficient of 1 plus 1, we need to make the bigger number here positive. So we make 2 into the positive number. Then if we multiply this out, we get x squared plus 2x minus x gives us just x plus x, and 2 times minus 1 is minus 2. So if we go backwards and multiply this out, we do get what we started out with, x squared plus x minus 2. We can factor the polynomial in the denominator in a similar way. The x squared will factor into x and x. Next, the number 6 here can factor either into 1 and 6 or 2 and 3. Since this is plus 6, both of these numbers should be positive. And because we have a plus 5 here, let's see, if we factor this, we would end up with plus 2 and plus 3, since 2 plus 3 is equal to 5. Once we factored both of these polynomials, we can look for common factors, and x plus 2 appears in both the numerator and the denominator. So we can cancel that out, and we're left with x minus 1 in the numerator and 3 multiplied by x plus 3 in the denominator. Some teachers or some textbooks want you to multiply everything out once we simplify the expression. Other textbooks want you to leave this alone, so the directions for what to do here will depend on which textbook you're using or what your teacher asks you to do. But in this case, I'll go ahead and leave the answer in this form with 3 multiplied by x plus 3 um, in, I guess, factor form like this.